Hello guys, so welcome back to LeetCode with AK. So I'm Aravind here. So today actually we are going to solve another interesting problem, but this is really very important because so most of the people is like fearing about that DB is a really tougher one. Definitely the dynamic program is really not a tough one. Not only the dynamic programming, to all the DSA concept is not a tougher one. The only thing is like you have to clearly that grasp the basics of the data structure, then only you can able to solve any problem using any DSA techniques. But today problem, we are going to, there is two different parts. The very first part, I will show you how to solve the problem using recursion plus backtracking. And the second part is a continuation of first part. I will tell you how to figure out whether the problem can be solved by using dynamic programming or not. If it is possible, then how to solve the problem using memorization technique. So this is really interesting. Please stick with me till the end. So guys, this is the very first part. Okay, let's move on to the problem statement. The problem statement is given by LeetCode as a problem, daily challenge problem. It's tagged as odd. I will explain you what is the problem. Okay, so the actually we have to figure out the tallest billboard. Okay, so you are installing the billboard, want it to have largest height. So the billboard have two steel support, one on each side. So each steel support must be equal height. Okay, so normally why we are using the billboard to install some banner and height. Okay, so what they are trying to say till here, so they are trying to install the billboard with a steel support. Okay, fine. So you're given the collection of rods that can be built together. Okay, so they give some example also, as well as we have to figure out the largest possible height of your billboard installation. If you can't support the billboard installation, they just return zero. So what they are trying to say, they are giving the list of array. So the array is containing the value of rod length. So they are giving the option to you. You can able to build any kind of any different rods, but the only thing is you have to find out the largest possible height of your billboard. If not possible, just return. The meanwhile, so if you are build any of different rod, definitely there might be a left part or right part or part one or part B. The part one and part B, the height of the part one and part B should be equal because only then we can install the billboard, right? So we have to find out the maximum possible height of your the rod length, which is useful for the billboard install. If not possible, just return zero. Just take this example. So what I can do, so I can stick, I can weld together one and through 1 plus 2 plus 3. Then I can simply take the fourth rod, which is having the length of 6. Okay. So what is the summation of this value is 6. So which means I can weld, if I can weld the 1 and 2, 3, I'm getting the rod with a length of 6. With I can use it at left side or right side. Then and I have one more rod with a length of 6, so that I can build two different rod with the same length. This is really the maximum possible, right? This is really the maximum. What is another possible? We can build this one 2 plus 3. 2 plus 1 equal to 3, and you can take the 3 as a separate rod. So these two, if you weld 1 and 2, you can get a 3, as well as we have the rod with a length of 3. So so we have, this is one of the possible way, but this is not a right maximum the possible one, because if all three weld together, you can get the rod with a length of 6. That is the maximum possible way. Okay. What about the other? So like if you weld 2, 3 equal to 5, and 5 plus 5, I mean 2 plus 3 plus 5, and simply take another side 6 plus 4. So if you weld, you will get a summation of 10. This part also you will get a summation of 10. In that case, the maximum possible is the rod with a length of 10. So, okay, what about this? Okay, if I weld 2 plus 1 plus 2, I will get 3. Is there anything left? Definitely not. Okay, I can't weld 1 and 3. Okay, is there any other possible? I can simply took 1 and 2. I can took 1 and 2. I can took 1 and 2. One can act as a left part, One can act as a left part and two can act as a right part. These two rod really the same? Definitely the length of the rod is not really the same. In that case, what is the output? If you can't support a billboard installation with the proper length of rod, then simply return 0. So this is the actual problem statement. I hope everyone clear about the problem statement. Okay, let's move on to this problem. How to approach this problem? So very brute force approach. Okay, I will tell you. Okay, let's take this example. Okay, just imagine what are all the possible way actually we can do. And the very first step, I can pick the rod with a length of 1. Okay, I can pick, as well as I can don't pick, right? You can pick, either don't pick, because in this case we are not picking this one. So what is the possible? See, if you are starting this way, either you can pick this rod or you can don't pick this rod, because I'm not worrying about the stuff. Either pick or don't pick. Okay, let's say if I'm picking this one. So what is the next possible? The next possible rod with a length of 2. So what are all the possibility? Pick 2 or don't pick 2. Okay. So the very first step, you can pick or don't pick. What is the third step? In start step, you can pick 3 or don't pick 3. So this is the third step. So this is clearly illustrating either you can pick or don't pick. Okay. So pick or don't pick is clearly illustrating in 0, 1 abstract. 0, 1 abstract problem is nothing but if you are giving any other problems, either you can pick the particular index value or particular item or don't pick the item. So that is the that is a two possible way you can approach this problem to find out the maximum possible. So this is clearly illustrating the 0, 1 abstract problem using recursion and backtracking. Why we are okay, recursion and backtracking. Why we are concluding this problem can be done by using recursion and backtracking with a 0, 1 abstract, because each step you have two different possibility. Either you can pick the particular item or don't pick the particular item. So that's why actually I'm concluding this. This problem can be done by using recursion with backtracking technique using 0, 1 knapsack approach. Okay, let's move on to the problem. How to so every step. Okay, I'm starting this 1, 2, 3, 6. Okay, so the very first step, I will pick the rod. So and I don't pick the rod. Okay, so if you are picking the rod, what is the size of the rod? 0. If you are not picking the rod, what is the size of the rod? 0. Sorry. If you are picking the rod, then obviously the rod length would be 1. If not, it would be 0. So this is for index 0. Okay. This is for index 0. In next step, index 1. So what is the other possibility? Either pick 2 or don't pick 2. If I am picking 2, okay, so what is the rod length? Rod length will be 3. If don't pick, the rod length will be 1. In this case, if you are picking the rod with the length of 2, the length will be 2, otherwise the length will be 0. So again, if index equal to 2, in that case, again there is two possibility. Pick with a rod with a length of 3, so totally is 6, and pick with a rod with a, don't pick the rod with, okay, so in that case 3. So this will, okay. Same approach, pick or don't pick 3. So pick, if I picking, then option will be 4, then don't pick 1, pick with option equal to 5, don't pick 2, here 3, here 0. Simple. And the final one, index equal to 3. So what is the final? So what is the final? In that case, either pick or don't pick, right? So what I can tell, what either you can pick 6 or don't pick 6. So this is how it, the recursion problem will go down here. This is a simple the demonstration of the recursive tree. So since I can't able to draw some line between each other, the recursive line, So it's not clearly illustrating, but this is a very basic step. Each step you're iterating pick or don't pick, pick or don't pick. So these two options, if you are not picking, then you have to add a particular rod in a rod value. If not picking, don't add, then move on to the next part. So this is a very basic step. Okay, then let's move on to, but in this problem you have to clearly should understood there is a two different part, right? Left part and right part, right? So in that case, what you have to do, uh, you have to pick for both left and right, and don't pick. So this will be the approach. So I will tell you how to solve this problem. So let's take this example. Okay, let's take this example. Okay, const rod equal to, okay, this is my problem. Okay, okay. What is the function is given in the code? Okay, I'll just copy paste this. I will tell you how to. Okay. Okay. So what I do, definitely this problem can be done by using recursion and backtracking. So I will write a separate the solve method. So I will pass the rods. Okay. Simply I will pass the rods. So what I need index, as well as I need a left summation of, I mean the height of the left part as well as height of the right part. Okay. So let's check. What I have to do, I have two options, right? Three options. So option equal to solve. So rods. So each step actually you're saying you're picking for both left and right part, and don't pick. So if you're picking, so definitely, even though if you're not picking or not picking, definitely you have to increase the index. Then meanwhile, what is the summation of left part? This is a left part. I'm going to pick the particular rod. Okay. I'm picking for left part. Option, this is option one. This is option two. Yeah, this is up in that part. What I'm doing, picking, I'm adding the rod length. I mean, I'm welding the rod length for the right part. Okay, okay. So what is the final stuff? Option three equal to don't pick anything. Simply don't pick anything. Okay, in that case, nothing will be added. Simply nothing will be added. So you have to find out the maximum possible in that case. So max option one, option two, and that option three. Fine. So what is the base condition? So for every recursion problem, definitely you have to be worried about what is the substructure and what is the base condition. So this is the really the substructure is pick for left part, pick for right part, or don't pick. This is the substructure. Okay, fine. This is a sub problem. If you're solving this sub problem, there is there is one huge problem. You're going to the recursive tree. You're solving sub problem of each is recursive tree, so that everything is solved and finally will solve the biggest problem. I mean your top problem. Okay. In that case, just these are the three sub problems. And what is the base condition where I have to stop? I have to stop once I'm iterating all of the index values. Let's see. Okay, what is my index value? If index equal to your length of rod length, in that case, I tried all the possibility for all of the rod, right? So what I have to do, I have to try, there are two different possibilities, pick or don't pick. I have to try all the possibility for all given rod. Okay. In that case, if the index equal to rod length, in that case, definitely I tried all the possibility for all of the given rod. Then simply return, check what I have to do. My left and right part is same or not. If my left part and right part is same, just send any of the left part or right part, because you need highest possible rod rate, right? In that case, I'm just checking my left rod and right rod, both are same. In that case, I will simply return any of this stuff. If not, simply return 0. So that is what mentioned. If can't able to support a billboard, simply return 0. So this is the actual the recursive problem. So what you have to do, you have to simply call this recursive method. That's it. That's all about the problem. I'm starting with index 0. Initially, my left part also 0, my right part also 0. I will simply return the. This is very simple brute force approach to solve this problem. Okay. Actually, recursion and backtracking is really very, very basic stuff in order to get strive in the dynamic programming, because the problem can be solved by using the recursion backtracking. There is highest possibility to solve the same problem using the dynamic programming. Military part, definitely please try to go recursion and backtracking, then proceed for dynamic programming. Then coming back to the time and space complexity. What is the time and space? Actually, in each step, I am trying for two possibility, pick or don't pick. On the pick for the particular pick, I'm trying for left and right. So there is three possibility: pick for left part, pick for right part, or don't pick. Simply don't pick. Okay. So three different possibilities. I have to try for all the given route. So which means 3 to the power of n. Okay. 3 to the power of n. Okay. What about the space complexity? I'm not using any extra array apart from the given input. So what about the space complexity? In recursion and backtracking technique, definitely your recursive tree would occupy some space. I mean the recursive stack. So auxiliary space complexity. Why I'm strongly saying auxiliary space complexity? Because let's say you keep on calling this method. I'm for this particular index, actually I am calling the index 0, then it will move on, it will come to 1, then it will move on, increase the index, it will move on till it reaching the last index. So what about the remaining value? I'm calling one method, it's in my recursive tag, which insidely calling the another recursive call. So it's keep on calling. At one particular case, my base condition is met, everything will be popped out. So that's why I'm telling I'm not using any extra space, but my auxiliary space complexity specifically for recursive stack would be O of n, because at final, if you are going deeper, finally you will it index 3 that will return one by one. So what is the maximum possibility of your recursive stack would be O of n. Finally, once everything done, obviously the stack size will be vanished, but that's why I'm telling I'm not using any pen, but auxiliary space complexity would be O of n. This is all about the first part. The second part is really very interesting, how we are going to solve this problem using dynamic programming. For if you solve this problem using dynamic programming, definitely pretty much sure, actually I promise you guys, definitely you will get some good knowledge about how to solve the problem using dynamic programming. Please wait for part 2. Definitely I will visit soon. Thank you so much, guys. Thank you so much. Meet you soon.